Okay, so we're going to go through this real quick, guys. This is 4.3. This is factoring and permutations, okay? So basically what a permutation is counting the number of ways oh, this is all messy in here. Just going to erase some of this. This is counting the number of ways a group of objects can be arranged. Now this arranged part is pretty important because when we get into other groupings, arrangements will mean permutations, okay? So the number of n permutations of n distinct objects all taken at a time, okay? So the formula that they use for this is it's called NPR. And you should have this button on your calculator. Typically, it's a second function. It might be in with the number keys. So sometimes it can be tricky to find. So if you hit like second function, I don't know, like 6, it might show up. Or it's going to be, if you have one of those Texas Instrument ones, it's going to be on the PRB button. Okay. You hit PRB just like when you're finding factorials. It'll bring it up and it should see NPR. So you'll put the first number in, hit NPR, and then put the second number in. Now, the formula, you don't need to memorize it because your calculator does all this, but NPR, where N is your total amount, total number of objects, and R is the number you're picking, the amount you're picking. So for example, let's say you have 20 people and you only want 6 of them. So you would say your total number is 20, your R value is 6, so it'd be 20p6. And the formula, just in case you want to know how it really works, is you take your total amount, you go n factorial divided by n minus r factorial. And that's the formula. And you can use this formula and use it on your calculator, it'll work just fine. Or, hear me out, you can use your calculator to do it for you. Okay, so let's look at this first example here. There are 10 different books. How many different ways can they be arranged on a shelf? Well, there's 10 of them all together, so n equals 10. And the amount that you're using is 10 as well. So you would just go 10p10 on your calculator, try it out. You should get something like 3,628,800. Or another way you can do it is you can use the fundamental theorem of counting, like we were the other day. And down here I made 10 dashes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you just count out, well, I have 10 choices for my first book, 9 for my second, 8, 7, 6, 5, 4, 3, 2, 1, which is 10 factorial, which is also 3,628,800. And 10 factorial is also, if you use the NPR button, remember the formula up here, so that would just be 10 factorial divided by 10 take away 10 factorial. So that's just 10 over 0 factorial. Now, fun fact, 0 factorial is actually 1. So it's just 10 factorial divided by 1, which is also this. Okay? I know I'm going a little fast, so if you have any questions, pause and make sure you email me, okay? Now, determine the number of permutations for 5 candidates' names on a ballot. So you have 5 people and you're choosing 5. So again, it's 5p5 or 120, which is 5 factorial. Whereas if you made your dashes for 1, 2, 3, 4, 5 names on a ballot, 5 for your first choice, 4, 3, 2, 1, and so on. Okay? Now this one here, a baseball coach has determined the batting order of his baseball team, and he knows he wants the pitcher to bat last. So if you make 9 dashes here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 players on the team, you know your pitcher's pitching last. So let's go to our last dash here. And let's put that in. How many choices do you have for there if it's the pitcher? You have 1. And then you have 8 choices left over for your first batter. 7, 6, 5, 4, 3, 2, 1. You multiply all those together, you're going to get 8 factorial, which is actually 8 picking 8, 40,320. Okay? Now, next question is, use your calculator to determine 12p8. Try that out. That's just going to be 19,958,400. Now, the next one here is, you have 10 books and you only want to choose 4. Well, now that's just 10p4, 5040, 5,040. Or if you did the dashes, 1, 2, 3, 4 dashes for 4 books, 10 choices, 9 choices, 8 choices, 7 choices. And that's also the same value there. For the next example, a popular rock group has written 30 songs from which it selects to perform at a concert. How many different opening sequences of 3 songs can they perform? 30p3, 24,360. Okay, now let's go through this one here. Tanya needs to create a password. And she needs to use any digits from 9 to 0 or any letter in the alphabet. The password is case sensitive, so she can use upper or lowercase letters. A password must have at least 5 and a minimum of 7 characters long. Each character can be used once. In the password, how many different passwords are there? Okay, well, let's go through and count out what she has. She can use the digits from 0 to 9. So there's 10 in total. She can use the letters from A to Z, A to Z, and there's 26 of those, times 2, so there's 52 letters. So in total, she has 10 digits and 52 letters. So in total, she has, I'm just going to do this, 62 choices, right? Now, she has to choose 5 and to a maximum of 7 characters. So that means she could choose 5 characters, so that would be 62p5, or she could have 6 characters, which would be 62p6, or she could have 7 characters. It doesn't say. So we got to figure out the total for each one and then add them together. So that's going to look like this. So you take your calculator, punch it in, 62p5. So these are going to be big numbers. 776, 520240. And as you're going, you can add them together. Plus, I would recommend doing that. Let's see here, 62p6. This is now 4.43 times 10 to the 10. So these are getting big. And then you got 62p7, which would be 2.47 and 2.48 times 10 to the 12. So if you were to add those all together, you're going to get, so you take all your totals, add them together, you're going to get something like 2.52 times 10 to the 12. That's how many different passwords you could have. So you can see the more choices you have and the longer you make it, the more safe and secure your passwords. Because the more choices you have, the harder it is to hack. Okay, I know this was a quick video, but I just thought I'd make this one quick and fast so you guys would have it. So go to page 252, do these questions here, 5, 6, 8, 9, 10, 12, 13, and 15. And good luck.